Whenever your phone sends data, millions of small pieces of information travels through the air. If every transmission were placed randomly, communication would completely become chaos. To solve this, transmissions are organized in two dimensions in 5G NR. A two-dimensional resource grid was introduced in 5G NR. Every transmitted symbol is assigned to one precise location inside the grid. Let's start with the smallest unit in the resource grid. Let's look into smallest part in the resource grid. Each column in the grid represents the OFDM symbol, and each row represents the subcarrier. Together, they define one resource element. It is the smallest physical resource defined in 5G NR. In NR, resource element is represented as one subcarrier in frequency domain and one OFDM symbol in time domain. After modulation, every symbol is mapped into one resource element. Some resource elements carry user data, and some carry reference signals, and some carry control information. In NR, resources are not assigned in terms of number of resource elements. Instead, 5G groups them together as 12 consecutive subcarriers over one OFDM symbol, which is called one resource block. The entire carrier band has hundreds of resource blocks. As it contains many resource blocks, each block requires a unique address. In 5G NR, the resource block numbering starts from the beginning of the carrier bandwidth. The resource blocks, which are in the entire bandwidth, are called as common resource blocks. But your phone is not capable of using entire bandwidth. In LTE, bandwidths are very small, so processing is not a big deal. But 5G bandwidths are much wider. To receive the entire bandwidth, the UE has to process every resource block, which means larger FFT sizes and more memory and more processing and higher power consumption. So, instead of asking the UE to process the entire bandwidth, the network activates only the part it currently needs. UE now processes only part of the bandwidth, which is called bandwidth part. The entire carrier bandwidth still has common resource block numbering. Suppose this is the active bandwidth part. Inside the active bandwidth part, the resource block numbering is changed. The resource blocks which are present in the active bandwidth part are called as physical resource blocks. Notice carefully, nothing physical has changed, only the numbers have changed. Everything begins with the carrier bandwidth. The resource blocks inside the entire carrier bandwidth are called as common resource blocks. The transmission happens only in the bandwidth part. The resource blocks which are present in the bandwidth part are called as physical resource blocks. The scheduler maps symbols onto the virtual resource blocks. 12 consecutive subcarriers in one OFDM symbol is termed as resource block. Each subcarrier in the resource block is called as resource element. Finally, the transmitted symbols are mapped onto resource elements.